Hello, everyone. My name is João. I am the CTO for GoContact, and today I'm going to speak to you about serverless in a telecommunications environment. So let's start about addressing what is serverless. So serverless technology is referred to when the developer that is deploying the programs has no control or management under the underlying servers where those programs will run. The word in itself is kind of tricky because it will lead you to think that there is no server. And that, of course, is not the case. For a function or a program to run, you need a server. But you don't have to own or manage that server, okay? So AWS is the leader in this space with AWS Lambda. But Google Cloud, Azure, and many others have come into this space, offering what is called functions as a service. The basic idea is that you upload your code, usually an HTTP-enabled function like a REST API, to an ecosystem that will expose this interface to your clients, usually over the internet, of course. You do have some control. For example, you are usually obliged to choose what programming language and interpreter version will be run to ensure compatibility with your codes. But even this is a compromise, since you can only run some programming languages and some versions of those programming languages, and you might be forced in the future to keep your codes up to date with the latest version of those programming languages. Okay, so serverless basically is a trade-off between not having to host, manage, and run your servers versus flexibility and control. So if you want speed and agility, you can forego control, and serverless might be the way forward for you. Okay, so what are the main use cases? Okay, so one thing to have in mind is that serverless is still in its infant days. We are still early in the container orchestration revolution, and there is already a new tech on the horizon that is serverless. The main use cases today are simple, CRUD-like operations that are exposed through HTTPS requests to an API interface, usually using the REST pattern. So basically trivial stuff like retrieving or setting data into a database that is also probably being used as a service in that particular app. But more and more, we see something that I'm inclined to name as architecture as a service, like Google Firebase, where you have the basic and advanced building blocks for a globally distributed mobile and web platform. I'm amazed at this, really, to be honest, because single-handedly, I was able to build a mobile and desktop app written in Flutter with a simple backend deployed to Firebase functions, that is serverless, using Firestore real-time database and Firebase storage. So by servicing this app through Google Play and Apple's App Store, I am now able to get my app to run on any country in the world with the same level of service as a big company that has like dozens of DevOps guys running around handling their servers. So all of this in a couple of months coding, just a couple of hours per week. Yes, I know I have signed a contract with the devil since I am bound to Google services, but the trade-off is unlimited scalability, global reach, and a virtual zero maintenance on the infrastructure. So it's a pretty good contract with the devil. So what are the challenges? Well, as an open source guy, the main challenge I felt with the mix of serverless and as a service stuff is the inherent lack of control. And I keep wondering when will it fail and if Google will be there to fix it as soon as I need it, okay? So also the lack of flexibility is staggering. Their services either do or don't do what you want, okay? If they don't do what you want, then your best course of action is to just change your product. Or, you can build a clunky workaround, but most cases that's a bad choice. So there is no room to evolve whatever they have running in the background just for your use case, right? So pricing is another issue, but to be honest, I'm a bit on the fence on this one, okay? So there are two big contributors to pricing when you run your own stack. The price of the hardware and hosting that hardware. the price you pay, usually in salaries, to maintain and scale that hardware. Also applies to services, not just hardware, of course. So when it comes to serverless or as a service, the economic units are different. So the big contributors are usually a per consumption unit, like per call, per CPU unit, per storage gigabyte, per data gigabyte transfer, etc. And the quality of your code and the workflows you implement and the general architecture of your application. Okay, so this is something that most companies are not usually inclined to think of as an economic unit. Okay, I'll explain in a bit. So in both scenarios, usually companies that are doing a financial comparison between them are not able to estimate with precision or lack of bias the second point of each, namely the amount of people you need to run your systems, so hardware and the services that you're running on that hardware, and the impacts of your architecture or code quality or workflows decisions that will have on the price. Okay, so at GoContact we run our own data centers, meaning that we rent floor space in the big data center where we put our own cages in with our own networking stack, our own servers, etc. And the reality is that hardware and scale decisions are usually interconnected with business decisions, meaning that you might have to put up a couple of new servers because that's what you need right now to close a deal, right? But if you had an extra 6 months, you probably just free up resources on existing servers. So these kind of decisions stack up with time, right? And it's why it's so hard to be right on forecasting costs. And usually this is what is motivating big companies to move to the cloud. So I can draw a parallel with the gig economy. Why should you pay a full-time worker when you can pay per task, right? Yes, if you do the math, per task is more expensive, but we, as humans, suck at forecasting. So it's just better to pay per task and have the flexibility. So coming back to my experience with Firebase, I can also say that with simple but wrong choices, you can easily 10x your monthly bill. For example, in Firestore, the database as a service, you pay per query. And the price of each query is calculated with the number of documents that the query has to go through to return the wanted results. So let's say that you want to get, let's say, all the female records of a customer database. So that query needs to read both male and female records. So you will pay each time to read the entire database, even if just the female records are returned. So another option is to build the architecture in a way that female and male records are in separate indexes, so that when you run this query, you only be paying for what you actually need. This, of course, is very easy to understand, but very hard to implement, as you would need to know beforehand the exact queries that you're going to run and then design your database pattern around this. And it can get real clunky real fast, okay? So what happens in the real world is that database design is driven by the application implementation. And this only becomes a problem when you're already in production scaling, and then you are faced with the decision of refactoring or paying the devil its dues. So what is the current state of operational models? So basically, most of what we have is either dedicated servers or VMs. So today in the real world, most of what's running, especially in telecoms, is bare metal, so dedicated servers or VMs. Yes, we are always talking about evolution and the next big thing, but most innovation happens in people's heads and not in the physical world where stuff is more prone to stay in rest. This doesn't mean that we should not push to advance the state of the art, but we should be careful when doing so, because Infrastructure reliability is a delicate balance between stability over time and incremental improvement, right? So usually when you hear someone advocating for a complete replacement of the status quo with the new shining toy, they have no skin in the game and no past experience in servicing real-life customers with a high level of quality demand. So having said that, we do need crazy guys like Elon Musk to come in once in a while and break stuff so that we can leap past our current inefficiency. So right now, there's a big shift to containers and orchestration, namely Docker, okay? But there are a lot of challenges around this when it comes down to implementing telecommunication stacks with the same design patterns as we see in the web application space, okay? So in my mind, Docker and other container solutions were designed to be small, simple, and short-lived, okay? That's why the orchestration layer, like Kubernetes, is so concerned with dynamic scaling and container health check. So if you design a platform to be a monolith that needs to be up most of the time, let's say because they're not stateless, for example, then it's counterintuitive to run such a platform on a short-lived infrastructure, right? So another big issue is that these container services are usually behind load balancers, and those load balancers don't like to speak anything other than HTTP. They also don't like long-lived connections to the containers, as it makes it harder to kill, scale, and generally move stuff around in the backend. So that's another big incompatibility with the current telecommunications applications, as you easily have persistent connections between peers that are routed through a SIP server not speaking HTTP and a media gateway to enable stuff like transcoding, recording, mixing, etc. Okay, there have been some advances on this end. Mainly there's a very interesting RFC proposal called RIP, so that's REPP, that aims to take advantage of the third version of HTTP and the concept of UDP streams to implement an alternative to SIP-based communication. Of course, this is still very much in theory, since we all know that these kind of changes take years to be relevant in the real world, since everyone has to adapt to it, okay? We all know also that it's possible to put together a stateless architecture to get two people to talk over WebRTC, or even like a PSTN SIP connection. But the challenges and limitations are such that you wonder if you want to do it just for the sake of doing it, right? So CPass. So CPass is the new kid on the block, okay? So according to UC Today, CPass in 2020 has a market size of 7 billion, okay? We have seen Twilio and the likes of it skyrocket into the global scene, rendering traditional carriers useless, to the new developers coming up to the shores of unified communications. We watch as new applications are built in record time, scale up in months, what took traditional companies decades, and play on the global scene like it's the new normal. Having said that, we can't forget that the total telecommunications market is worth around $1.8 trillion. So CPass is actually just a drop of water in the ocean, right? So the potential is so staggering that we are just wild guessing at the future where telecommunications is going. And you can't forget that Elon Musk is working on Neuralink, right? So true CPass has introduced serverless to telecommunications, okay? So it's the same concept. With CPass, you can just call up an API to dial, answer, establish a session, send SMS, etc., all with just HTTP requests and without even wondering what the servers and networks are doing in the background, right? So as a developer, I can just write web code, okay, like web code to implement all the hard stuff of telecommunications. And, I can laugh away into the sunset while I hear old school guys talking about how hard it is to get telecom stuff running, right? This is, of course, a joke, but it's becoming the norm. Yes, you still have the complexity in the background. So traditional carriers are part of this architecture solution as well, but we can't forget a new breed of network is rising, and with enough time and reach, we will see a combination of factors coming into play that can disrupt traditional carriers in such a way that not even legislators might be around to save them. On the one hand, you have Twilio, and on the other hand, you have all these companies like Facebook, AWS, SpaceX, trying to build the new infrastructure for internet based on satellites. So coming back to the point, with the existence of CPass, isn't serverless already a reality? Well, the answer is yes, but no. Okay, so CPass does provide part of the stack as a service, but most of the code that is being written to make use of CPass is still being deployed in a traditional manner, not being run over serverless. So actually, if you want to have the real deal, there's still a good way to go. And actually, CPass providers can be the enabler for this. Like, for example, Twilio just launched what they call Twilio Runtime. And this provides a kit for serverless. So you should check that out. Okay, so who is driving this change? Okay. In my opinion, we live in amazing times. Companies are competing with each other at such a pace that is staggering, the amount of innovation that actually hits the real world each year at increasingly lower prices. Users, of course, drive the markets, but not like they used to. We as consumers are in a historical point of our roles as we shifted from wanting companies to build something to just sitting back and watching companies run themselves to the ground trying to please us. So let's take Netflix, for example. It's not enough to mail you a DVD and kill Blockbuster. I'm going to stream thousands of titles on a global distributed network with zero downtime. And wait, we're not done. We feel that you're not getting the content quality that we think you should. So we're also going to build high quality series and movies to keep you entertained at all times, just for like $10 a month. That's like a movie theater ticket price per month to have everything catered to you and your family at all times. So all of this would be literally impossible like 15 to 20 years ago, and is now regarded as the norm. It's mind-blowing. So users, consumers are driving the change, but not with demand, through adoption. So monthly active users is the metric that makes or breaks empires today. Not profit, not revenue, not politics, monthly active users. So developers are a scarce resource, and they are pushing for the shining new thing. We are seeing this with containers. So Twilio and other CPass also track monthly active users, of course, but their users are actually developers, not the end user. And most of their users are web developers, like probably 90+% are web developers, and maybe not even 1% of their users are actually telecom guys. So think about it for a second. CPass is driving the change in telecommunications. CPass is bound to monthly active users, and their users are web developers. Okay, so who is really behind the wheel? So developers are probably today the world's scarcest resource. Salary prices are rocketing everywhere. Cities are being built to please developers. Companies go head over heels to hire a couple of more, you name it. And developers like to focus on developing, right? The amount of guys actually liking, DevOps, IT stuff is really, really low. Most of what's happening out there is web-related stuff, and all the rest is niche. So web developers drove the need for VMs, and then drove the need for containers, and then drove the need for short-lived containers, Docker, for example, and are now driving the need for a serverless or as a service everything. So they don't want to care about infrastructure. So they keep pushing the agenda because they can. Okay, so we probably interview around 20 developers per month at GoContact, and most, if not all, want to work with containers. Okay, it's just a matter of time until they want to work with serverless. And we will all be pushing our stacks high into the cloud just to make sure we're still attractive to developers as companies, right? So we are being pushed further and further away from the network, from the operating system layer. So serverless and as a service pushes us all further away from the basics of architecture. This is not comparable to the shift from hard languages like C or Java to scripting language like JS or Python, where you have huge productivity gains being traded off over low-level control of the underlying systems. So serverless and as a service is a giant leap to a new paradigm where the abstraction is such that you will easily take for granted the complexity behind it, right? So it's like ignoring the complexity of the electrical grid and the production systems every time you turn on the lights. Should you bother with it as long as the lights are up? So my personal opinion on the matter, okay? So personally, I feel it's still early, but that the speed of adoption is increasingly faster, okay? So the economies of scale of as a service are potentially huge and can't be ignored. As a hardcore open source systems guy, I feel like, I don't quite belong in the new age. But I have to admit, as a business guy, that this is a lost word. So serverless and as a service is actually the next big thing. So we will see huge disruption in telecommunications driven by a mix of events like the standardization of CPass, the appearance of internet access by the new carriers where the traditional carriers don't have a say, and the push of thousands of new startups leveraging this stuff on a daily basis. So telecommunications, as we know it, is old. Okay, it's too old. It's highly regulated. It's rigid. It's centralized and static. Yes, this means that it works all the time, right? And you don't want to mess with the basic building blocks of society, and telecommunications is one of them. But it also means it's begging to be disrupted, just like energy, just like finance, just like transportation, right? So serverless, the new carriers, and monthly active users are going to drive the disruption. And we, as telecommunications guys, we need to choose whether we're going to be part of the solution or the problem. So looking forward, I can't help to think that we need a strong open source project around CPass and serverless. Yes, you can get your current open source stack like Camarate, OpenShips, Asterisk, or Free Switch stack. You can build your own CPass with it, but that doesn't cut it. It's still your old stack with a brand new wrapping, right? So if we want open source to be a part of the new world in telecom, then we need to rethink the whole architecture and come up with something that is compatible with the short-lived, stateless, globally available, and distributed architecture that developers demand these days. So if we come short of that, it's not going to be enough. So I just want to finish by saying that we live in wondrous times. I'm very excited that we are on this turning point, and to be honest, I can't wait to see what we're going to build next. Thank you everyone for listening. If you have any questions, just drop me an email. I'll be glad to continue this conversation. Thanks.